Okay, how it works this. Okay, welcome. My name is Alex from the company James. James is a shortcut for JEDIT, additively manufactured electronic sources. So there's no need to remember that. What is important to remember is what we are doing is we work in the field of 3D printed electronics. So the PCB manufacturing and the PCB development and design exists for decades. And there's, from my point of view, not that much evolving in this field. So we have basically the same process. So shouldn't we think about to change this manufacturing process of electronics? So should we not leave the way of the traditional PCB manufacturing? But let's get one step back to explain what does it mean to us, 3D printed electronics. So let's talk about the E in AME. So in the first step, I think I don't need to explain this. The AM world is quite common to you because here on Formnext you see a lot of examples. So this means this is driven by mechanical requirements without any electrification, without any electrical requirements. When we go then the next step, and we call it this in our world 2.5D, but this step in between is needed to come to the real three-dimensional structures. So here we're talking about to adding electric requirements. This means printing on surfaces or having those MID structures, molded interface devices. So that means this is the first combination of electronic and mechanical requirements. But this last step, this is what we want to achieve. Fully three-dimensional structures. This means embedded components, free 3D wiring, no layers anymore, no wires, and also replacing components. This means today we are able to design and print, for example, capacitors. With limits, sure, but we are able to print them. There's no need to put a component out of the shelf. We can replace this by our design. Some sample applications to make it more clear to you, what does it mean? The first one is, and I think you can see where it can go to. This is a PLL cube, we call it. The PLL stands for phase-locked loop. This is more or less a RF frequency generator. And here you can see the evolution of, you cannot see, okay. You can see the evolution of the application. Above, the traditional PCB, then some evolution steps, we try to stack it, and at the end, we're having such a small cube. So this, I would say, is a very good example how we can combine the mechanical and electrical requirements with AME. So this is a very stable form with embedded components, 3D wiring, and it's not easy to break instead of the PCB, for example. I also have this example on my booth, so if you want to have a look on it and want to take it in your hands, just feel free to pass by and have a look on it. The second one is our 3D printed drone. So this is one single print and also a very nice example of the combination of mechanical and electrical requirements. So here you can see this is one single print, no stacking needed, no cables anymore, and also the motors, the wiring of the motors are printed. So you only need to add the components and you're ready to fly. Next one is a very easy and simple application. We call it NFC coin, and this is in our platform. I will explain later on what does it mean. A very simple entrance story and sample application to get into this topic. So this is NFC, and here you learn how to use this technology, how to design such things. Another application, this is a power regulator from one of our partners, from the company Fuji. So this is also a combination of the mechanical requirement, so those holes for the screw, and also the electrical requirement, and is printed in one single print. This was implemented in a customized robot arm where they don't have much space, so it was needed to have a very small solution and to print it in one single print. Okay, let's talk about why should we print electronics? What are the benefits to do it? First one, I think this is quite clear, the form factor. This is, you can have a look around here, you see many cool samples from additively manufacturing. We can create any form or color, and we want to have the same freedom like the AM have in our world, in the electronics world. Second one, from the electrical point of view. If you imagine you do not have any layers anymore and any wire holes, this means you don't have no 90-degree angles anymore. And if you have a smooth angle to connect components and short ways to connect them, then the signal integrity is much better. So from the electrical point of view, it makes also sense to print electronics and to bring the components together. Third one, and I think this is also very easy to understand from the sustainability point of view. If we are comparing the traditional PCB process with up to 25 process steps and a lot of energy consumption and a lot of chemical waste that this process produces, in comparison to one printer, then the sustainability aspect is much better than the traditional one. Last one, also from the system point of view, I mentioned it already, like this cube, for example. So you have much more stable solutions, and so it makes sense to also print those things. What is the current technology status? To be honest to you, so we are not on a level of mass production, I would say. We are talking about a TRL of 5, 6, something around that. So we can do prototyping, we can do mid and low volume series with this technology right now. Before I come to the challenges we have with this technology, I would show you this picture, because this is a detailed picture of this printed capacitor in the NFC coin. So this is a close look to it. So this is a printed capacitor in this solution. We are facing a lot of challenges in this field because the technology is a bit young. So the first challenge we have are the design tools. Currently the situation is you have to use an ECAD tool, you have to use an MCAD tool, and you have to merge it manually. We as James are in very close contact to the big software companies like Altium, Suken, Siemens Mentor, Dassault Systems, because what we need in this field is a 3-dimensional auto router. We don't have it yet, but hopefully in the future, very soon we will have it, because it makes no sense to have a great technology with a high potential, but from the beginning of this process you cannot design things. So a design tool is needed. Second one, process stability and reproducibility. This is getting better and better, so the improvement is there, but sometimes it happens we're having the same application, the same settings, the same engineer, but another result. So this is definitely a way that we need to, or a topic that we need to improve. Next step is norms and standardizations. Maybe if you know something about the PCB design and PCB world, they have a lot of standardizations. So we also need this in our world, because a short story regarding that. We had a project with a defense company where we have had a very nice antenna solution made by AME. We passed all our environmental tests and started to come into a fighter, but the last instance that was able to certify the solution said, no, you cannot go with this application to a fighter because I cannot certify it. I have nothing to certify. So this is a completely new technology. We need something, a standard or something that we can use to certify you for this project. So then from the technical point of view, everything was fine. We passed all the tests, but at the end, we were stopped because there was no standard available for it. So the standard topic is definitely a very important challenge now we are also working very closely with IPC and also German associations to define something and to improve this also. Last one, accessibility. To get into this technology, this means you need to invest into a machine. Sure, this is important. Or you find someone who provides a printing service. And the second topic is you need to invest in know-how, because currently we have the situation, we have an electrical engineer who is in charge for the electrical design, and then a mechanical engineer who is in charge for the mechanical design. But when we combine those things, the engineers need knowledge from both worlds. So they need to understand, how can I create such things in a three-dimensional way? So this is also a thing that companies need to invest. Okay, how to proceed and what is James, what we are doing in this field? We as James, let me say, we are a neutral instance about this whole technology. We created a network and a platform, a digital platform, where we bring all the information and all the ecosystem together. This means we are having all the printer manufacturers on one hand, the process owner, because inkjet, this was the sample what you have seen, where also, everything was printed by inkjet. But inkjet is not the holy grail and not the only one process. There are not a lot of things out there. So the second one, we have a lot of research in universities, institutes. They are doing a lot of cool things. And on the last hand, we are having the industry, because they don't know this technology right now. And if they know the technology, they don't know how to use it or how to start with it. What we in James are doing is we provide all the knowledge. We are helping the industry to get easy into this technology, or as easy as possible, I would say. We are sharing our knowledge. It's an open source community, so every one of you is invited to join and have a look on this technology. We are sharing applications. You can download those applications, you can play around with it, make your own experience, and give us feedback. And then we are convinced that we can accelerate the development of this technology all together in an open source community and also with crowd development, I would say. This is the idea behind James, and we are also providing consulting and supporting the industry to starting projects, sure, and also we are providing printing service in this way. Yeah, I told you we have a partner network, and I think you can see a lot of big names in it. For example, Fuji from Japan is also in our network since the beginning of this year. Also, XTPL is a very nice company from Poland. They are doing really cool stuff in microdispensing. And Nscript is a US company, so we're having partners worldwide. And yeah, so this means we can help you with your application to find the right process, to find the right partner, and to start with this 3D printed electronics topic, because we are convinced this will be the future. We will not replace the PCB completely. This is not the goal. We want to become a very good additional technology to them. And with this technology, you are able to reduce your cycle times in development and to produce prototypes tremendously, because you can make your design at the end of your day. You can put your design into the printer, it prints overnight, and next day you can grab it out of the printer and test it if it works. If not, you can do another cycle till the next day. So no more waiting times for PCBs from somewhere, so you can print it directly next to your desk. Thank you so much for your interest and for your attention. If you want to know more about it, or if you want to see some awesome samples that I have shown here, just come to our booth, Hall 12.1, C71. We are part of a pavilion from Bayern Innovativ, Bavaria Innovative. We have a small booth there, and but all samples are available. You can take it in your hands, and we can have a conversation about this very interesting topic, I think. Thank you so much.